Welcome aboard one and all to another video on representations of data. This is the second in the series, the second in the chapter, and today we're going to be looking at cumulative frequency diagrams. Before we get started, as ever, there are some warm-up questions for you to have a go at. So here they are. There's only 3 today. So try these on your own, press pause now, and then just press play when you're ready to check your answers against mine to see if you've got them right or not. Okay, so pause the video now, and when you're ready, press play. So let's have a look together at question number 1. So a class of students took part in a French vocab test. The teacher gave each student a score out of 10, and we're asked to draw a box plot for the following summary of the data. So we've got the 5 main things with which we plot a box plot with. Lowest value, the quartiles, the median, and the highest value. So these 5 values relate to 5 vertical lines we plot. First of all, though, we need a numerical scale, so we could add this on like so. Scores from 0 to 10. We've got the lowest value is 1, so let's add this in. Lower quartile is 3. Median of 5. Upper quartile is 6. And then the highest value is 9. Then what we need to do, we need to make this into a box by putting a horizontal line on the top and the bottom, and 2 lines from the lower quartile to the lowest value and the upper quartile to the highest value. So to finish it off, we do this. And that's the complete box plot, and that's question 1 complete. Let's have a look now at question 2. Question 2, we're talking about outliers again. So an outlier is a value more than 1.5 multiplied by the interquartile range above the upper quartile, or if it's a low-lying outlier, 1.5 multiplied by the interquartile range below the lower quartile. So use this information, we need to calculate the upper and lower boundaries for outliers in question 1. So just reminding you of what question 1 was, we had these values. So from these we can calculate the interquartile range. So for question 1, and question 2 of course, the interquartile range, VIQR, is the upper quartile 6, minus the lower quartile, which is 3. 6 take 3 is obviously 3. Then 1.5 multiplied by this interquartile range just means 1.5 multiplied by 3, which is 4.5. So 4.5 is this value here, which has been mentioned. So now what we can do is we can now calculate the boundaries for a outlier on either side. So an outlier, or outliers, need to be less than 1.5 times interquartile range, 4.5, below the lower quartile. So it needs to be less than 3 minus 4.5. In other words, it needs to be less than minus 1.5, which is clearly impossible for a score. You might be able to do badly on a test if you don't revise. I'd very much doubt, though, you can get less than minus 1.5 out of 10. If you do, come and see me. You must be miraculously terrible. On the other hand, on the higher end, an outlier would have to be larger than the upper quartile, which is 6, plus 1.5 multiplied by the interquartile range. So 6 plus 4.5, in other words, it'd have to be bigger than 10.5. And again, if you're able to get a score of 10.5 out of 10 on a test, please come and see me as well, because you are miraculously amazing. And so these are the 2 options. Either less than minus 1.5, which is impossible, or greater than 10.5, which is, again, impossible. So it stands to reason, quite obviously, for part B, that this dataset can't have any outliers. So we need to state the obvious to answer the question just by summarising. So it has no outliers because no value is less than minus 1.5, obviously, or greater than 10.5, quite obviously. Finally, for question 3. Again, question 3 relates to question 1 and question 2. So we need to decide if these following statements are true or false. So just to remind you what we had from questions 1 and 2, we have this here. So question 1 and question 2, we've got this, and the box plot as well, which we drew from question 1. So part A, it says 75% of the class got at least 3 vocabulary questions correct. Well, 75% of the class, the 75% point, that is the upper quartile. So the 75% point actually relates to all of the values from the upper quartile downwards. Okay, so I've just drawn an arrow in red which shows you the 75% point. In fact, I'll just alter that to like this. So that's what we're after. And so actually it's wrong, because you can see from this arrow that 75% of the class, which is all the values up to the upper quartile, got 6 vocabulary questions correct, because 6 is the value of the upper quartile. This question would have been correct if it had said 75% of the class got at least 6 vocabulary questions correct, or if it said 25% of the class got at least 3 vocab questions correct, because 25% is the lower quartile, which is 3 questions. So for this one, we have to say this statement rather, is false. For part B, it says 50% of the class scored between 3 and 6. So now we need to consider which bits of this graph are between 3 and 6. Which bit of this box plot, rather, between 3 and 6. So between 3 and 6, we've got here all the values from the lower quartile up to the upper quartile. The lower quartile begins at the 25% point, the upper quartile ends at the 75% point. So this box here is the middle 50% of the data. The middle 50% of the values are between 3 and 6, which is what this statement is saying, therefore this statement is actually true. Lastly, 25% scored 3 or less. This is false, because actually 25% scored 3 or less. 5 or less, 5 is the median. So if this question had said 50% scored 5 or less, that would be right. But 25% is here, which is actually 3 or less, not 5. So for that reason, part C, this statement is false. So now we're suitably warmed up, let's have a look and talk about some cumulative frequency diagrams. So, where to begin? When data is presented in a grouped frequency table, you are not able to calculate exact values for the median, quartiles, percentiles, etc. We've already seen how linear interpolation can provide useful estimates, but we can also use cumulative frequency diagrams to read off estimates directly. So we've got a worked example here about a cumulative frequency diagram. So first of all, we've got a table which shows a lifetime in hours of 80 light bulbs. So for part A, we have to complete the cumulative frequency entries for the data in the grouped frequency table. So first of all, we need to just remember cumulative frequency is just simply a running total of the frequencies. So the first cumulative frequency is the same as the first frequency itself. So we begin with 3, so the first cumulative frequency is just 3. The next one, we do 3 plus this next 18. So 3 plus 18 is 21. 21 plus this next value of 20 gives us 41. 41 plus 33 gives us 74. And finally, 74 plus 6 takes us to 80. So that's all we need to do for part A. Part B, draw a cumulative frequency diagram on the grid provided. So on your worksheets, on your notes, you'll have a grid. So we should have something looking a bit like this. So we need to draw a cumulative frequency diagram. You can choose whichever scale you want, but I would suggest to try and use as much as a graph paper as possible without making the scale really awkward. So if using the whole graph paper means you're picking a scale of each square is 0.17, that would just be awkward and very problematic. So try and make a scale sensible and use as much graph paper as you reasonably can. Don't do a tiny graph. Tiny graphs are harder to read. So here's what I'd suggest you do. You don't have to, but I'll show you my scale in a second. Just to remind you as well, these are the entries from Part A, and the scale I'd suggest would be something like this. So the lowest value is 20, and the highest is 30 hours. So I suggest just one big square going along is worth 1 hour. And no need to start it from 0 because our data doesn't begin at 0. So we can use a broken scale, which is fine, and label this axis lifetime in hours. Of course, we need a vertical axis for cumulative frequency. So for the vertical axis, I'd suggest each big square going up is worth 10 values. So at the top we've got 80, the bottom we can start from 0 and label this cumulative frequency. We now plot the cumulative frequencies and always plot from the endpoints of the intervals. So first of all, we plot at the endpoint of the first one, which is 22, and go up to 3. So this point here is 22 and 3. The next one we'd plot would be 24 and up to 21, like so. The next one, 26 and 41. Then 28 and 74. And finally, 30 and 80. You'll notice there is a characteristic shape with cumulative frequency diagrams. It should always look a bit like an S. So it starts off going shallow, goes up, goes steeper, and then flattens out as you get to the top. If you can, try and draw through these points with a smooth curve. Go through with a smooth curve. If you really absolutely insist that you can't do it with a smooth curve, you could do these with straight lines with a ruler between each point, but if you can, please try and have a go at doing them with a smooth curve. I'll try and do it now, but I've got a backup. I've cheated earlier. I'll show you how it might look if you did a really nice curve with practice. So just to show you, I'm not very good at doing curves either. Up through this one. See, I've missed. How embarrassing, but I'll keep it in the video just so you can see how bad I am. I won't hide or lie. So go up through this point, then steep through that point and flatten out until you got to there. Now you can see how wonky that is. So it takes practice, but at least the examiner will see you've had a go. Like I say, I did cheat. Here's one I've made earlier. That looks much better. So now we're going to use this curve in green to read off the values for the next parts of the question. So part C says to estimate the median and interquartile range. So if we've got 80 values, that says that the median has to be halfway along. Half of 80 is 40, so the median is going to be the 40th value. So the 40th value is going to be reading off at 40, then going down. By the way it looks to me, my estimate for the median would be about 25.8. Next, the lower quartile. So the lower quartile is going to be 1/4 of 80. 1/4 of 80 is 20. That tells us that the lower quartile is a 20th value. So you're going to read along from 20 and go down and see what value that gives us. So according to my diagram, at least, yours might be slightly different. You may have drawn your curve differently to mine, which is fine. I get a value here of about 23.8 hours. And The upper quartile, which is the 60th value, because 3/4 of 80 is 60, we go along at 60 and go down when we hit the curve, so we go down to this point here. So that is my estimate of the upper quartile. Looking at this, I would say it's about 27.1 on my graph. So the interquartile range is going to be Q3 minus Q1. So the upper quartile Q3 I think is about 27.1. The lower quartile Q1 looks to me to be about 23.8. So we do 27.1 minus 23.8, which comes out at 3.3 hours. So the middle 50% of data, the middle 50% of the light bulbs should last between 3.3 hours, from the lower quartile up to the upper quartile. Part D, we need to estimate the 10th to 90th interpercentile range. So first of all, we need to work out what 10% of 80 is. 10% of 80 is 8. Then we work out what 90% of 80 is, which is 72. That tells us, therefore, that the 10th percentile is the 8th value, and the 90th percentile is the 72nd. We can now read off these points on the cumulative frequency diagram, just as we did for the quartiles. So the 8th value, we go along from the 8th one up and go down when we hit the curve. So according to my graph, I get that to be about 22.6 hours for the 10th percentile. We then do the same for the 90th. 90% of 80 is 72, so we're going to read off at the point 72 and go down when we hit the curve, which looks something like this. So going along and going down, we see here that's about 27.8. So the 90th percentile is going to be about 27.8 hours. And the 10th to 90th interpercentile range is going to be the 90th percentile minus the 10th percentile. And that gives us 27.8 minus 22.6, and that gives us 5.2 hours. So from the 10th percentage point to the 90th percentage point, that's 5.2 hours in terms of lifetimes of the light bulbs. Question part E, estimate how many bulbs lasted longer than 23 hours. So for this one we need to think about whereabouts 23 hours is on the horizontal scale, on the x-axis here. So we read on the cumulative frequency diagram, but rather than going along and down, this time I'm going to go up and across, starting at 23 hours. So we go up until we hit the curve and go along and estimate here what the cumulative frequency would be. So as you can see on mine, it's about 12 light bulbs. So that tells us that 12 bulbs lasted up to 23 hours, because cumulative frequency means up to and including that particular value. So 12 bulbs lasted up to 23 hours. There was 80 bulbs in total, so that tells us that 80 minus 12, which is 68 bulbs, must have lasted longer than 23 hours, according to our estimate. So our answer for part E is approximately 68 bulbs that lasted longer than 23 hours. F, it says draw a box plot to represent the data on the grid. So we just put together the bits and pieces of what we've done previously for the different parts of this question that have come before. So here's the grid for the box plot on which we need to plot it on. And of course we need to have a numerical scale. And so I'd suggest keep the scale nice and simple. Each big square across could be worth 1 hour. So do it from at least 22 to 30, like so, and then think about what the 5 main points are on this box plot. So the lowest possible value is 22 hours. There's no knowing what the actual lowest value was. So what we do is we take the lowest possible value according to the class widths and the class intervals. the lowest possible value it could be is 22. So that's our estimate for the actual lowest value. Next, from part C, we worked out an estimate for the lower quartile was 23.8 hours. And so I'm going to do a vertical line at 23.8 on my box plot grid. Then the median, again from part C, we calculated was approximately 25.8 hours. So we do a vertical line at 25.8, and again from part C, we worked out an estimate of the upper quartile, so we can add this on. We got the upper quartile estimate was about 27.1 hours, and so again we add this onto the grid, like I have done here. Finally, the greatest possible value, according to the class intervals, would have been 30 hours. This is where the class intervals end. I'm not saying the greatest value was actually 30 hours, but we just take the maximum value at the end of the interval as our estimate for the maximum actual value. Now we've got the 5 main vertical lines which make the box plot. The final thing we do is just add on the horizontal lines to make these 3 here into a box, and horizontal lines joining the lowest to the lower quartile and the highest to the upper quartile. So to finish off the box plot, we just do this, and we're all done. So that's a worked example, and cumulative frequency questions often follow a same sort of structure. So what is important is for you to have a go on your own. So without further ado, if you can turn to the book, page 47 and 48, exercise 3C, and try the 4 questions on there, questions 1, 2, 3 and 4. You know the drill by now. Check your answers on your own. If you get stuck or make a mistake, try and work out first and foremost on your own where you may have gone wrong. If you're still unsure to see where you've gone wrong on your own, then ask me, either in class in person, on an email, or on the comments section in this video. Thanks very much for watching the video. I hope you found it useful. Keep working hard, and I'll see you all very soon in lesson. Thanks again. Goodbye.